right, let's graph some lines. So in the book, in this section, they're going to want us to graph lines using the intercepts. We have the x-intercept and the y-intercept. The x-intercept is the point where the graph crosses or touches the x-axis. The y-intercept is where the graph crosses or touches the y-axis. And the way we find either is you set the other variable equal to 0 and then solve for that variable. Okay, so let's do the following. So I'll make up some of these. How about 3x plus 4y equals 12? Let's graph this one. Okay. So they want us to use the intercepts. So for the x-intercept, you're going to let y equals 0 solve for x. Okay. Y equal to 0, solve for x. So 3x plus 4 times 0 equals 12. So we've got to do a little algebra. Of course, 4 times 0 is just 0. You have 3x equals 12. At this point, you have to divide both sides by 3. So you get x equals 4. So if x equals 4, and earlier we said that y was 0, then that's the ordered pair for 0. So 1, 2, 3, 4. Okay. Now we have to find the y-intercept. Y-intercept. Same thing, you're going to let or set x equal to 0 and solve for y. So we set up our equation, 3 times 0 plus 4 times y equals 12. 3 times 0 is 0. 4y equals 12. Divide both sides by 4. And you get y equals 3. You always put the x-coordinate first. So if x is 0 and y is 3, that is the ordered pair 0, 3. So we plot 0, 3. 1, 2, 3. Now, you can plot other points if you want. Once you graph those 2 points, or once you plot the intercepts, all you have to do is connect those points with a line, and that'll give you the graph. Let's do another example. This is in standard form. We'll do something in slope-intercept form. You don't have to know what these forms are necessarily right now, but I just wanted to give you some different practice. So 3x minus, we'll say 6. Okay. On MyMathLab, if you end up with a fraction for one of your intercepts, you can click on the point and you can look underneath the graph and you can edit it. So if one of your intercepts that you found algebraically was like 1.5, 0, but it won't let you graph it, then you can click on one of the points and then click to edit it, and then you can change it to the decimal or fraction that you need. But since we're doing this on paper, I'm going to choose nice, easy numbers. All right, so this is the same thing. X-intercept, let y equals 0, solve for x. Sorry, solve for y, solve for x. All right. So y is 0. This is going to be the tricky one. You'll see why. It's not even that bad. But 0 equals 3x minus 6. 0 equals 3x minus 6. Here we actually got to do some algebra. What I mean by that is, well, I got to add this 6 to both sides. 0 plus 6 is 6. 3x minus 6 plus 6 is 0. So I have 6 equals 3x. And just like before, if I divide both sides by 3, move over here, x is equal to 2. And so if x is equal to 2 and y is equal to 0, that is the ordered pair, 2, 0. Okay. I'll mention this warning down at the bottom in just a second. So let's plot 2, 0. 1, 2. All right. For the next point, we'll do the y-intercept. Let x equals 0, solve for y. So this one's going to be a lot easier. I could have started with it, but I wanted to be consistent if I did x-intercept first here and then y-intercept second. So y equals 3 times 0 minus 6. Y equals 0 minus 6. 0 minus 6 is minus 6. Of course, that's the ordered pair. X is always first, and then y. So be careful of that. 0 minus 6. 1, 2, 3, 4, 5. I'll have to cheat that a little bit. That's okay. 6, we'll say, is down here. So that's minus 1, minus 2, minus 3, minus 4, minus 5, and then this is down here, minus 6. On my math lab, when you plot these points, it will often, when you click on the point, it'll show you what the coordinates are. So if you don't have good eyes and you miscount, you can click on the point and it'll tell you what the ordered pair is. All right, let's see what this warning means down here. So in this chapter, unless it's otherwise noted, you'll have to plot using the intercepts only. So there are many other ways to plot lines or graph lines. There's a slope-intercept form, point-slope form, but in this case, for these assignments, particularly in the second half of the chapter, we have to use intercepts, so we've designed it to where we'll always just use intercepts to make it easier. Okay? All right, so let's move on. Well, we just graphed lines that were not vertical or horizontal, so let's look at some lines that are vertical and horizontal. Okay? So a horizontal line has the equation of the form y equals b, where b is the y-intercept. So let's just draw a horizontal line. Okay, so this guy, horizontal, it's going through y equals 2. So this is y equals 2. So this one, well, let's do it this way. To stay consistent here, let's call this just b. Okay. So this is the form, it has the form y equals b, where b is the y-intercept. And I'll do the same thing down here with my vertical line, where we'll have a vertical line that goes through the x value of a, whatever a is. In this case, here it is, right here. And if it's vertical, it has the form of x equals a, where a is the x-intercept. That's just to kind of demonstrate the difference between vertical and horizontal. So let's take this example, x equals 3, we know that's going to be vertical, but what I want to show you is a couple of ways that we can graph it. What I find is students will confuse horizontal and vertical. They'll mix them up. So I'm going to graph it using a table as well as our knowledge that since it's x equals 3, it has to be vertical. So let's do that part. First, x equals 3, we go out to 1, 2, 3. We draw a vertical line. So this is what it should look like. Let's use this red. Okay, so a lot of times, especially if it's horizontal or vertical, they'll kind of write. Sometimes they'll write what the equation is in the textbook. All right, so if you understood the vertical versus horizontal, there you go. If you don't, if you get confused with horizontal and vertical, some people struggle with left and right, so, whatever. If you get confused with horizontal and vertical, make a table like this. So I'm going to use this example to demonstrate how I could use a table, and you can apply it for a horizontal line. So it's kind of like a T-table. I'm going to have a column for X, a column for Y. I'm leaving a little space, and then my ordered pair X comma Y. And what I need to do is find like 3 points. 2 is good, but 3 is a little better. Okay, you can find as many points as you want. Now in the equation, if you're confused with horizontal versus vertical, then, line this up, it's always going to be x, y, x, y. So in this case, they tell us x equals 3. That means each of these rows is 3. So if it was y equals 3, each of these rows would have 3 under the y. So I can choose any value to plot. So I will do 0, 1, and negative 1. Generally, I like to stay around the origin or those values. So 3, 0 is a point. 1, 2, 3, that's right there. I'd already plotted that one. 3, 1 is right here. And 3, minus 1 is right here. When you plot these online, you only need to plot 2 points, and it'll graph the line for you. But yeah, you could choose any point. If x is equal to 3, I'm just doing a 4th point for fun, and y is equal to 5, then that's the point 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. So there's a 4th point, even though you don't need it. Okay. So if you get confused with vertical versus horizontal, plot it using a table. There you go.